So finding complex zeros. This is just like what we did Friday, but some of our answers are going to be imaginary. Remember, that's what a complex number is. Any number that can be written in a plus bi form. So it could be any real number, any imaginary number. Now, the first step, read the first step to yourself with your eyeballs, please. The first step says list all possible zeros. What do you remember from Friday's lesson and the test you took on Monday about how to generate the potential zeros for this expression? Where does it come from? The last number, right? The 12. So we do our little squiggly wigglies because we're going to list stuff. What are factors of 12? 1 and 12. What else? 2 and 6, 3 and 4. All right, so we're going to list them. But I'm still missing something. What am I still missing? Perfect, thank you. Plus or minus. So this is my bank of potential zeros. How many total is there? Looks like 6, but not 6. It's 12, right? Because we have the plus versions and the minus versions, okay? All right, so there's step 1. We just listed all the possible zeros. Read step 2 to yourself, please. Step 2 is to test 1 and -1 with synthetic division. Now, you could really just randomly pick any number and test it. You could pick -4, you could pick +6, but because 1 and -1 are so easy to do math with, it's just a more systematic way of beginning. That doesn't mean they'll necessarily work every time. It's just a good place to start. So we're going to start with 1 and just test it out. And when we go to write our coefficients, we have to check for missing x terms. And there is a missing x term. Which one is missing? X. So that should go between the -5 and the 12. And that's where we're going to use a 0 placeholder right there. So the coefficients are 1, -3, 3, -5, 0, and 12. And I want you to take a minute and you do your synthetic division. And Zoom, I'm going to freeze the screen so people can't see your answers in case that makes you nervous. When you've got your remainder, please put your answer in the chat so I can see what you got. And if you're watching the video from home, please pause now and find your remainder. All right, so I got 8 for remainder. By the way, I'm talking to the video right now. So I got 8 for the remainder, which means x equals 1 is not a 0. So then continuing with step 2, I tried -1, did my synthetic division, and I do have 0 for a remainder for -1. So what that means is x equals -1 is a 0. And that also means what is a factor? X plus 1, right? X plus 1 is a factor. All right, so I'm going to circle this -1 here just to hold my spot so I can come back to that information later. Because remember, the point of the problem is to find the zeros. And so we're trying to get it into factored form because that's how we'll figure out what the solutions are, or the zeros. That's why it can be daunting. It can be. That's why we start with the 1 and -1, because they're just easy places to start. And then if those don't work, that's right. It is a trial and error method. All right, so at this step, when we add our x's back in, what power of x would I need to write for this first term? If I was adding them back in now. X to the 4, right? So before I write all that out, let's imagine something for a second. So we have these coefficients right here after our first round of synthetic division. And if I was adding my x's back in, I would have this. I would have x to the 4th minus 4x cubed plus 7x squared minus 12x plus 12. And that's 5 terms. And we do not have a factoring method for 5 terms. Okay? We have a factoring method for 4 terms. We could try grouping if we only had 4 things. But the problem is that we have 5 things. So what that means is we have to do another round of synthetic division. Because what happens each time we do synthetic division is not only does the degree go down by 1, but we lose 1 term. The whole expression gets shorter by 1 each time we do a round of synthetic division. So if you read step 3 to yourself, it says, and obviously I'm going to read it out loud too as well. Continue testing zeros as needed. And we do need to in this case. So what we're going to do is pick some other 0 to test from step 1, that bank of potential zeros that we created. And as someone in class pointed out, that seems kind of daunting. Like you could just be trying the positive and negative versions of those numbers like all day, right? Well, luckily, I'm here. And I'm just going to tell you what to try next because I know it's going to work. But when you're doing your homework, yes, you will have to just trial and error your way through the problems. But for this moment in time, I'm going to tell you that 2 works. So we're going to do a round of synthetic division with 2, but you do not use the coefficients from the original problem. You're going to use the highlighted ones because we're right here now in the middle of the problem at 1, -4, 7, -12, and 12. If you just went back to the original problem for this next round of synthetic division, you wouldn't have improved your situation. You would still be at 5 terms, and you can't factor 5 terms. So we're sort of doing, not sort of, we are doing synthetic division on these coefficients right here. The 1, -4, 7, -12, and 12. Okay, so do your synthetic division. You should get 0. How come we're not using what? Because if we did, we would just be back at the same problem where we still have 5 terms and we can't factor them. So if you think about, see these things that I highlighted right here, the stuff in yellow? If you were to add your x's back in, you would have this. We're trying to get the expression short enough that we can use one of our factoring methods. Like for 4 terms, we can try grouping. For 3 terms, we could try that cross method. But 5, yes. So after this next round, we'll have 4 terms, and we could try grouping. Grouping will work. In the case that grouping didn't work, you know what we would do? Another round of synthetic division until we found it. Yep. All right, so 2 works. Not a surprise. I set you up for success on that one. That means x equals 2 is a 0. And it also means what is a factor? What factor goes with x equals 2? X minus 2. Thank you, Paul. So x minus 2 is a factor. So then step 4 says finish factoring, use factors to find zeros. So now that we have gotten down to 4 terms, we can add our x's back in and try to do factor by grouping. What degree x am I adding back in at this step? Cubed. Very good. Very good. The step before, we were supposed to have added in x to the 4th, but since we did another round of synthetic division, we drop our degree by 1, and now we're adding in x cubed. Exactly. Every time we successfully get to 0, not every trial and error one. Mm-hmm. Yes, exactly. That's a good question. Yeah, so by round of synthetic division, I mean a successful round of synthetic division. So we're at x cubed minus 2x squared plus 3x minus 6. We're going to factor by grouping. You do your grouping, I'm going to do mine, but don't watch me do mine because then you can't unsee it and then you think you understand and maybe you don't really understand. So we got to x minus 2 and x squared plus 3 from the grouping. We bring down the x plus 1 and the x minus 2 from earlier in the problem. And then we write our repeating factor with an exponent of 2, x minus 2 parentheses squared. That factor gives me a solution of x equals 2, and we call that a double root. And then the third factor, so I'm saving the middle one for the last. So I'll get to that in just a second. The third factor gives me a solution of negative 1. But the middle factor, x squared plus 3, is like our special factor for today, our special circumstance. So I'm going to come over here. This is where we get, this is where we get the complex zeros part of the lesson. So x squared plus 3, we can't just do insider's lie on that one and say the solution is negative 3. That only works for linear factors, but this is a quadratic. We want to know what values of x will make x squared plus 3 equal to 0. So we are just going to do some side work and solve this by literally setting it equal to 0. How do I begin? So looking at that green work I have on the side, solving for x, what's the first thing I need to do for x squared plus 3 equals 0? Subtract 3, okay? So that gives me x squared equals negative 3. What do I do next to both sides? Square root, perfect. When you take the square root, it's going to give you a plus and a minus version. And remember, what's significant that's going on inside there? There's a negative. So we talked earlier in the year how I like to break that up into negative 1 times 3. The 3 cannot simplify, right? You just have to leave square root of 3 like that. But what is the square root of negative 1? I. So that comes out as I. We sound like pirates. I. Positive, negative, I rad 3. How many solutions do you see there? Looks kind of like just 3, right? But there's 5. There's negative 1, positive I radical 3, negative I radical 3, 2, and 2, because the 2 counts twice. So there's 5 solutions, and that's what we were looking for. Okay? Any questions about that? All right. You have the rest of class to do the homework sheet